Hello students, this is Dr. Anita Raj, your chemistry mentor, welcoming you for one more session in surface chemistry. Today we shall see the purification of colloids. Okay, see under this category, under this topic, we have dialysis, electrodialysis and ultrafiltration. Okay, we shall see one by one now. Okay students, so the first method is dialysis. See, actually this method involves the removal of dissolved substances from a colloidal solution by means of diffusion through a suitable membrane. Okay. See here in this method they are making use of a suitable membrane, and that membrane will be allowing only the ions and some other molecules but not the colloidal solution. Okay. See, the colloidal particles cannot move through this membrane, but other ions and molecules that are present in the colloidal solution as impurities can be removed. Okay. So thus apparatus used for this process is called as a dialyser. Okay. The apparatus used for this process is called as dialyser, and the membranes used are the animal membranes. Okay. See, the different types of membranes here it's given that a suitable membrane should be used. Okay. So different membranes are used here in the dialyser. Actually, what are the different membranes used? See, animal membrane, okay, skin, right? The skin of animals, and then parchment paper. Parchment paper can also be used, and also silicone sheet. So these are the different types of membranes, of the suitable membranes that are used in the dialyzer for dialysis process. Okay. See here, this animal membrane or the parchment paper or the cellophane sheet will be made into a pouch like this. Okay. And here this will be having the colloidal solution which is impure. Okay. So this is another diagram, and this is the dialyzing membrane. Through here we have the colloidal solution, and these dots are the colloidal particles, and the rest is the other ions or the molecules that are present as impurities in the colloidal solution. Okay, and this dialyzing membrane which is having the colloidal solution is kept inside another container which is having fresh water. Here we have the fresh water. Okay, so now what happens here? See, let me read once again. A bag of suitable membrane containing the colloidal solution is suspended in a vessel through which fresh water is continuously flowing. See here, the water is fresh water will be continuously flowing through this container or this vessel. Okay, so it will be going out, right? And now we have the dialysing membrane which has the colloid, okay, colloidal solution. Now what happens as time consumes? See here, this dialysis process is a time consuming process. Actually it is a slow process, right? See, what happens here is the molecules and the ions that are present as impurities will be diffusing through the membrane into the outer water. Understood? So the ions and other molecules which are present as impurities will be diffusing through this dialysing membrane, okay, into this water, and obviously the pure colloidal particles will be will be retained inside this dialysing membrane. Understood? And other particles, other impurities will be removed, and that will be flushed out because this water is continuously flowing. It's not there, it's a continuous flowing of water, fresh water is there. So along with this fresh water, the ions and other impurities that are present in this colloidal solution will be that are coming out of this dialysing membrane will be flushed out. Understood? So this is what happening during dialysis, right? Next important method is electrodialysis. Actually, see, as I told you earlier, this dialysis process is a slow process. Okay, it's a time-consuming process. That's why they have chosen this electrodialysis, because what's the difference between dialysis and electrodialysis is here in electrodialysis we'll be making use of electric field. Okay, electric supply will be there, so that the process will be a little fast when compared to dialysis. Okay, so let us see what is happening here. See, this method is used if the substance in the impure colloidal solution is only electrolyte. Understood? See, this method electrodialysis can be utilized only if the impurity present in the colloidal solution is electrolyte alone. It is electrolyte alone, okay? But in the other case, in the dialysis, we can make use of all the other colloidal solutions which are having different types of impurities, because all the impurities, membrane, parchment membrane, all the other impurities can be easily moving, okay? But here, it is possible to make use of only the colloidal solution which has the impurity as electrolyte as the impurity. Understood? So this is also dialysis but carried out by applying electric field. So here we make use of electric field, okay? But all the other things are the same. Here we make use of the same type of membranes, that is animal membrane or the parchment paper or cellophane sheet, okay? So here we take the dialysing membrane. Here we have the colloidal solution which has the electrolyte as the impurity. Okay. Now what happens is this bag is which is made up of the suitable membrane, maybe parchment or silicone sheet, whatever maybe it that is containing the colloidal solution will be kept inside the vessel through which the fresh water is pumped inside. Okay. So the fresh water will be continuously flowing out. Okay. And also one more thing, we have electrodes. Two electrodes are placed here, one anode and another one is cathode, and it is connected through a battery. Okay. So electric current will also be supplied continuously. So what happens here? What is happening here is because of the extra force applied with this electric field, the process of dialysis takes place very fast. That means the electrolyte, the ions that are present in the electrolyte will be coming out of this dialysing membrane, okay, to the fresh water. So consequently, what happens is, see, the respective ions will be moving towards the anode and the cathode. So the ions, since the anodes they'll be attracting, okay, the anions and the cathodes will be attracting the cations. So automatically the ions will be forcefully coming out and it will be taking place a little fast when compared to dialysis. Okay, so the ions will be moving here. Okay, and here we can see the ions collected, and obviously the ions will be flushed out to the water. Now what will be having here in this dialysing membrane inside? Only the colloidal particles, that is pure colloidal solution will be there. So let us read here, a bag of suitable membrane containing the colloidal solution is suspended in a vessel through which fresh water is continuously flowing. They are explaining this one. Okay. The molecules and the ions diffuse through the membrane into the water and migrate out to the oppositely charged electrodes. Okay. So here the ions will be moving to the oppositely charged electrodes, and obviously the pure colloidal solution will be left behind inside this dialysing membrane. Understood, students? This is what happening in electrodialysis. Okay. Okay, students, the last method is the ultrafiltration process. Actually, it is the process of separating the colloidal particles from the solvent and soluble solute in the colloidal solution. So, they are separating the colloidal particles such from the solvent used for the preparation of the colloidal solution and the soluble solute in the colloidal solution by specially prepared filters called ultrafilters. Okay, so here they are making use of specially prepared filters called ultrafilters, because in the ordinary filter papers, through ordinary filter papers, this it is possible for the colloidal particles also to come out. Okay, so through normal filter papers, but that's why they are making use of ultra filter papers. How they are preparing this ultra filter papers? Actually, ultra filter papers are prepared by impregnating the normal filter papers with collodion. Okay, by impregnating with collodion, right? So what's the process going on here is actually how to prepare this ultra filters. These ultra filters papers are these are soaked in collodion first. Okay, they are soaked in collodion and then they are hardened by formaldehyde. First they are soaked in the collodion and then it will be hardened by formaldehyde followed by drying. Okay, first soaking in collodion and then it is hardened by formaldehyde and finally they used to keep it for drying. So finally we'll be getting these ultra filter papers. This ultra filter papers will be allowing all the substances, okay, all the substances except colloidal particles. Okay, so this ultra filter papers will not allow these colloidal particles to pass on. Understood, students? See what is collodion? How it is prepared? Actually, it is a solution, right? It is a 4% solution of collodion. Is a 4% solution. Okay, it is a 4% solution of nitrocellulose. Okay, of nitrocellulose. It is a 4% solution of nitrocellulose. Okay, in a mixture of alcohol, right? In a mixture of alcohol and ether. Okay, so this collodion, what is collodion? It is the mixture, it is a 4% solution of nitrocellulose in a mixture of alcohol and ether. Okay, and this solution, this collodion is impregnated in the filter paper. So, and then it is hardened and then dried. Okay, and this collodion impregnated filter papers or the ultra filter papers will never allow the colloidal particles to come out. Okay, but it will be allowing other particles to come out. Okay, so this is the setup, right? See, this container is segregated into two. In this side, we have the colloidal solution, okay, and this is the ultrafilter membrane. what's happening here, these dots are the colloidal particles, okay. And when see, actually this ultrafiltration is also a slow process like that of dialysis, okay. So here we have to supply some pressure. Either we should apply some pressure or suction, okay. See here we are applying a pressure. Since we are applying pressure, what happens here is the solvent and other soluble solute particles will be moving out of this ultrafilter membrane, okay, leaving behind the colloidal particles. So the colloidal particles will be retained inside here, and other impurities will be going out, okay. So in order to speed up this ultrafiltration process, we are applying pressure or suction, okay. Since this ultrafiltration process is a slow process, understood. So the colloidal particles, finally we will be having the colloidal particles left out inside here in this compartment, okay. So this colloidal particles left on the ultrafilter paper are then stirred with fresh dispersion medium. So fresh dispersion medium is the solvent which we are using here for the production of this colloidal solution, okay. That is called as the dispersion medium here considered. So the solvent which is used, or the fresh solvent, will be used here, okay. If we are using water, then pure water will be used as the dispersion medium, and in that we will be stirring this ultrafilter membrane, so that we will be getting the pure colloidal solution. Understood, students? So this is what happening in the ultrafiltration process, okay. Well, fine, students, I hope you might have understood what I have taught today. Let me meet you with another important topic in my next session. Until then, it's Dr. Anita Raj, your chemistry mentor, signing off from you. Thanks for watching.